Welcome back to the deep dive. We have just a massive stack of sources to get through today. I was looking through the reports from yesterday, the 11th, and it feels like we're jumping all over the map.
It really does.
I mean, from the cornfields of the American Midwest to shipping lanes in the Middle East, down to Brazil, over to Malaysia. But what's wild is that when you line them all up, they aren't actually random.
No, not at all.
They're all hitting the exact same wall.
It really is a distinct signal, isn't it? You know, usually the news is a bit scattered. Some tech, some politics, maybe some weather. But yesterday, everything seemed to be telling one single coherent story.
So to kick us off, before we get into the weeds of gigawatts and shipping insurance, if you had to summarize the structural movements of yesterday in the simplest way possible, what's the headline?
If I had to put it in a single vector, it would be this. Acceleration meets physical constraint.
Acceleration meets physical constraint. Okay, let's unpack that.
Yeah.
Because acceleration is a word we hear constantly. AI is accelerating. The news cycle is accelerating.
Right. And we've spent the last few years, really the last decade, living in a world of, digital acceleration. We talk about AI, software, the cloud, instant financial transfers.
It feels weightless.
Exactly. It feels like you can just push a button and the world changes. But yesterday, the data shows that these digital ambitions are just slamming into the slow-moving, heavy realities of the physical world.
Okay.
I'm talking about power grids, shipping lanes, processing plants. We are seeing a massive friction between fast capital, the money we want to spend, and slow infrastructure, the things we actually have to build.
So the checkbook is ready, the code is written, but the power outlet just isn't there.
That is exactly it. And that mismatch isn't just a technical problem anymore. As we go through the sources today, you'll see it's becoming geopolitical and a deeply, deeply local political issue.
Well, let's dive right into the biggest, lightest example of this checkbook versus reality problem. You flagged a story out of Lebanon, Indiana. Now, usually when we talk about big tech or the future of AI, we're talking about San Francisco, maybe Austin, maybe a boardroom in New York. Why are we talking about Lebanon, Indiana?
Because that is where the rubber, or in this case, the concrete, is hitting the road. Yesterday, it was confirmed that Meta has started construction on a data center campus there.
Okay.
And we really need to pause on the scale of this because the numbers are staggering. This is a $10 billion project.
$10 billion. I mean, we get numb to these numbers, but that is the GDP of a small nation.
It is. But here's the thing. In the world of physical constraints, the dollar amount isn't even the most important number.
What is?
The power consumption. This is a 1 gigawatt class facility.
1 gigawatt. Okay, I have to stop you there. Gigawatt is one of those terms that gets thrown around in sci-fi movies. We all know the Back to the Future reference.
Right, the DeLorean.
But in the real world, for a utility company, what does 1 gigawatt actually look like?
It's enormous. To give you a sense of scale, 1 gigawatt is roughly the output of a standard nuclear reactor. Or it's enough to power about 750,000 average American homes. Think about that. Meta is planning to plug a load equivalent to a nuclear power plant or a city the size of San Francisco into a specific zip code in Indiana.
And they just plug it in like a
Right.
toaster.
Well, that's the friction point, isn't it? They expect this to come online by late 2027 or 2028.
That seems incredibly fast for something that size.
It is optimistic, and this is why it's our first type topic. This signals a fundamental shift in what you could call the physics of AI.
Okay.
If you look back at the last 2 years, the constraint on AI growth was computational capital. It was all about, can I buy enough NVIDIA chips? Can I hire the smartest engineer?
Right, the great GPU scramble. If you had the chips, you won the race.
Exactly. But that era is ending. The constraint has moved. It's no longer just about how many chips you can buy. It's about how much physical power and land you can secure.
Right.
We are seeing a physical transfer of the AI boom. It's moving from the abstract cloud to the concrete ground, and that creates what we call a velocity mismatch.
A velocity mismatch, meaning the tech moves faster than the power lines can keep up.
Precisely. Writing a $10 billion check takes a few seconds of board approval. You can transfer that money instantly. But building the high-voltage transmission lines, upgrading the substations, actually generating that 1 gigawatt of new power, that takes years. It involves permits, environmental studies, pouring concrete, stringing copper.
So you get this shear in the system.
That's a perfect word for it. The demand is instantaneous, but the supply is stuck in the speed of the physical world.
And I imagine this changes the conversation at the local level, right? I mean, this isn't just tech news anymore. If I'm living in Lebanon, Indiana, this is my backyard.
It turns AI into a utility politics issue, and this is a theme we're going to see everywhere. If you live in Indiana or anywhere near these massive clusters, the conversation is no longer about what cool chatbot is coming next.
It's about what?
It's about water rights, because remember, these things generate massive amounts of heat. They need water to cool down.
So it's a direct competition for local resources.
It is. It's a clash with the city OS, the operating system of the city. Residents start asking, why did my electricity rate just go up to pay for a transmission line that serves a tech giant? Why are we concerned about the aquifer? We are moving into a phase where the biggest obstacle for AI won't be government regulation from Washington or Brussels on safety or ethics.
It'll be what?
It will be a town council in the Midwest denying a permit because they don't have enough water or power capacity.
That is such a fascinating shift. We worry about Skynet, but the real stopper might just be a zoning board meeting.
Exactly. Watch for the friction over who pays for the transmission upgrades. Is it Meta or is it the local ratepayer? That political battle is just beginning.
Okay, so we have the grid acting as a constraint on AI. Let's shift gears from the power grid to the ocean. You mentioned shipping lanes. We have a situation in the Strait of Hormuz.
Right. This is our second deep topic, Hormuz and what we can call the logistics OS.
Now, usually when tensions rise in the Middle East, especially around Iran and Hormuz, the first thing everyone looks at is the price of a barrel of oil.
That's the ticker we all watch.
Did it spike?
Yeah.
But you're saying something else happened.
That's the traditional metric, yes. But yesterday, looking at the source stack, something more subtle but arguably more impactful happened. The U.S. issued updated navigation guidance for merchant ships passing through the strait.
Navigation guidance sounds a bit dry. Is that just a suggestion? Like, traffic is heavy, take the alternate route.
In the maritime world, it's much more than a suggestion. It changes the field manual for captains and for shipping companies. It's a formal, documented acknowledgement that the risk profile has changed.
It warns of higher risks of boarding, of seizure.
Exactly. So even if no shots are fired, the rules of the road have effectively changed.
Right.
And this is why it matters. The logistics OS, the actual mechanics of moving things around the planet, often reacts faster than the commodity price. Even if oil prices don't spike immediately, the transaction costs do.
Because of insurance, I'm guessing.
Insurance is a huge part of it. There's a specific type of coverage called hull war risk. When that guidance updates, risk algorithms at Lloyd's of London and other major insurers, they twitch. Premiums go up instantly.
But it's more than that.
It's also behavioral. I mean, think about the psychology of it. If you are a captain responsible for a massive tanker and you get this guidance, you change your behavior.
You're not taking any chances.
No. You might choose to take a slower, safer route. You might wait for daylight to transit. You might wait for a naval escort.
And all of that adds time.
And in logistics, time is money. Delays accumulate. This creates what we call membrane tension.
Membrane tension. I like
Right.
that image. Explain that a bit more.
Think of the global logistics network like a tight membrane or the drum skin. It's all connected.
Okay.
When you poke it in the Strait of Hormuz, even just with a threat or a warning, the tension vibrates across the whole skin. It's felt in ports in Rotterdam, in Shanghai, in Los Angeles.
So a delay in the Middle East becomes a missed delivery window in Europe.
Precisely. It creates an invisible tax. We don't see it as a line item on our receipts, but it's there. It's an invisible tax on the global economy caused by psychological logistics.
I see.
The industry changes its behavior based on the perception of risk before the actual supply is even cut. So, while everyone is watching the oil ticker, the real inflation is creeping in through higher shipping costs and slower delivery times.
It's the friction of the physical world again. You can't just digitally route around a strait if that's where the water is.
You can't, and that friction costs money.
So we have the physical grid constraining AI and the risk grid constraining logistics. Let's move to our third deep topic, which seems to combine physical rocks with high-level strategy. You got notes here on rare earth minerals.
Yes, this is a story about rewiring the midstream.
The headline here is that a Taiwanese team is in the U.S. evaluating rare earth mineral deposits. On the surface, that sounds like a standard trade mission.
It does.
Taiwan makes chips. They need materials. Why is this a deep dive topic?
It sounds standard, but if you look closer, it's a reversal of roles and a very specific strategic move. Usually the conversation about critical minerals is just about mining, who digs the rock out of the ground.
Right. The assumption is the U.S. has the rocks, but China does all the processing.
Correct. I've seen figures saying China controls something like 80 or 90% of the refining market, and that's the bottleneck.
Okay.
Think of it like baking bread. The U.S. has plenty of wheat fields, those are the mines, but China owns almost all the flour mills, the refineries.
It's a great analogy.
You can't make bread with raw wheat. You need the flour. So we have the raw ore, but we can't do anything with it because we don't have the mills.
And that's where Taiwan comes in.
Exactly. What happened yesterday is that the Taiwanese team isn't just looking to dig. They are looking to connect U.S. raw materials to Taiwan's advanced refining and midstream processing capabilities.
So they're trying to build a bridge over China, a way to get the flour without using China's mills.
They are trying to rewire the supply chain. This is what actual decoupling looks like. It's not a speech by a politician. It's the slow, expensive, technical work of building a parallel processing infrastructure.
But why Taiwan? Why doesn't the U.S. just build its own refineries?
We could, but it takes a decade, maybe more. Environmental permits, technical know-how, we outsourced that 30 years ago. Taiwan has the institutional capital right now.
Institutional capital, that's an interesting phrase.
It means minerals are now being treated as more than just commodities. It's about the contracts, the technology transfer, the alliance plumbing.
Okay.
Taiwan and the U.S. are trying to figure out if they can create a closed loop that doesn't touch the Chinese refining ecosystem.
And I imagine that is incredibly difficult to do. You're talking about undoing decades of globalization.
It's incredibly difficult and incredibly slow. This is another form of that physical constraint we talked about. You can want a secure supply chain today, but building the refineries and the legal framework to move that material takes years.
It really emphasizes that resources aren't just what's in the ground.
It's the capacity to process them. You can be sitting on a gold mine, but if you can't refine it, it's just heady dirt.
Okay, those were our 3 deep dives: massive power plants, shipping risks, and supply chain rewiring. But looking at the source stack, there was a lot more flickering on the map yesterday. Let's do a rapid-fire scan. What else fits this theme of physical friction?
Let's scan the global membrane tension. There were several smaller signals that really reinforce this theme.
Let's start in Brazil. What happened there?
Brazil is a massive logistics node for global food. Yesterday, protesters blocked access to a Cargill facility in northern Brazil.
And the implication?
It's a reminder that global food security often relies on very fragile physical nodes: a single road, a single port entrance. When a local protest blocks a facility like that, it becomes a hiccup in the global supply chain.
The butterfly effect, but with soybeans. Okay, moving across the Atlantic to Africa, what's the signal there?
We're seeing a shift in how the U.S. competes for minerals. The U.S. is financing something called offtake agreements for copper and cobalt in the DRC and Zambia.
Offtake agreements. Break that down for us.
Think of it as pre-ordering. You're buying the rights to the future production before it's even dug up.
So why is that a strategy shift?
Because for a long time, the strategy was we need to own the mine. But China already owns many of them. So the U.S. is pivoting. They're saying, fine, you own the mine, but we will buy the flow.
Ah, a financial layer over the physical one.
Exactly. If you can't own the factory, buy all the inventory.
Clever. Okay, back to the U.S., specifically Illinois. You mentioned utility politics earlier with Indiana. Is Illinois seeing the same thing?
Yes. Illinois is working on something called the Power Act. Its new state legislation aims squarely at regulating data center, water, and power use.
So the politicians are waking up to this.
Rapidly. This confirms the trend. State regulations are catching up to AI's physical footprint. We call this internalizing externalities. The free ride on local infrastructure is coming to an end.
And finally, let's go to Penang, Malaysia.
Penang is becoming a critical node for the Talent OS. New advanced packaging and testing facilities are opening there. This is the back end of the semiconductor process.
Why is this a friction story?
Because it highlights the human constraint. You can have all the robots, but you need specific human hands and minds to make the hardware work. Penang has built a cluster of expertise. You can't just copy-paste that talent to Arizona overnight.
So bringing it all together, we have Meta building nuclear-scale power demand in Indiana. We have ships slowing down in Hormuz. We have Taiwan and the U.S. trying to bypass Chinese refineries. When you step back from all that, what is the picture?
The picture that emerges is that we are moving from the era of abstract announcements to the era of physical implementation.
The party is over, and now we have to clean up.
In a way, yes. The party was the digital boom, the hype, the stock prices, the AI will solve everything rhetoric. Now we have to do the actual work.
And the work is hard.
It is messy. It creates friction. Whether it's the copper wires for AI in Indiana, the insurance papers for ships in Hormuz, or the refining vats for rare earths, the story of yesterday was about the hard, unglamorous work of infrastructure.
We're discovering the limits of how fast we can push the physical world to match our digital ambitions.
Exactly. The bandwidth of the internet is nearly infinite. The bandwidth of a copper cable or a shipping lane is not. And that is where the tension is right now.
So, for our listener who is trying to navigate this, what should they be keeping an eye on? Give us the leading indicators.
Two very specific, very boring things that tell you everything. First, watch state-level electricity bills in the U.S.
Not the sexy tech stocks.
No. Watch the utility bills. That is where the political fallout of the AI boom is going to hit first. If rates spike to pay for data centers, the backlash will be swift.
And the second thing?
Watch marine insurance rates. They are the canary in the coal mine for inflation. If the logistics OS gets more expensive because of tension in the Middle East, the price of everything else follows a few months later.
It's always the boring numbers that tell the real story.
Always.
Well, this has been a fascinating look at the plumbing of the world. It's a good reminder that behind every line of code, there's a wire, a rock, and a ship. Before we go, leave us with one final thought to chew on.
We spend so much time worrying about AI taking our jobs or becoming sentient, but right now, looking at the data from yesterday, the biggest threat to AI isn't regulation or rogue code.
What is it?
It's simply whether we can physically build enough power lines to keep it turned on. The future is being throttled by the grid.
The smartest mind in the world is useless if you can't plug it in. Thanks for listening to The Deep Dive. We'll catch you next time.